In the previous lecture, we have studied about what is a virtual function. Now, there are some rules for defining a virtual function. What is the first rule? Virtual functions cannot be static and also cannot be a friend function of another class. Now, we have done examples for virtual functions. We have seen that virtual function is related to objects. But what is the property of static? Static belongs to the whole class, so it cannot be static. And also it cannot be the friend function of another class because these are member functions of a class. What is the next point? Virtual function should be accessed using pointer or reference of base class type to achieve runtime polymorphism. Always remember, we are going to create base class pointer. The prototype of virtual function should be same in base as well as derived class. There are always defined in base class and overridden in derived class. It is not mandatory for derived class to override or redefine the virtual function. In that case, base class version of function is used. Now, what is the last point? It is possible to have a virtual destructor, but virtual constructor is not allowed. Means there is no thing like virtual constructor. Now, the next topic is the difference between early binding and late binding. Most of the differences now you know, but here it is a summary of early binding and late binding. Now, your compile time polymorphism or early binding is also known as static binding. Your dynamic late binding is also known as dynamic binding. Now, in early binding, the compiler makes decision regarding the selection of appropriate function to be called in response to function call at compile time. Means linking of function call to the function body is actually done at compile time. But in dynamic binding, the decision regarding the selection of appropriate function is made by the compiler at runtime. Means when the program is actually under execution. What is the next point? During early binding, compiler consider the type of pointer and a particular function call is decided there only at compile time. No concern is there of what type of object address is assigned to base point. If you remember, we have seen that the pointer was of base type, and in case of early binding, it was always calling base class pointer. It was actually saying the type of pointer. In case of runtime polymorphism, compiler determines the type of object at runtime or address of what type of object being assigned to the base class pointer and then binds the function call. Next is all the address information required to call a function is known at compile time. Here all the information is known at runtime. Here you have the lack of flexibility because all the decisions are made early at the compile time. It offers flexibility as compared to compile time polymorphism, and all the decisions are done at execution or at runtime. Since all the information needed to call a function is available at compile time, so early binding is faster. Obviously, if you know all the information earlier, execution will be faster, and if sometime is resolved or a function call is resolved at a runtime, then the polymorphism will result in somewhat slower execution. Now, how early binding is achieved or implemented? Using function overloading, operator overloading, and it is achieved through virtual function, pure virtual functions, and abstract classes. Now, we have already done the programs for early binding, late binding, but here I have done a small program that indicates the difference between early binding and late binding. Now, if you see, I have a class base. One function is virtual, another function is non-virtual. Void print show. In derived class, again print and show. Means whatever functions I am having in base class, the same prototype I am having here. The functions are overridden, but one function is virtual, one is Non-virtual means this will work at runtime. This will be compiling. Now, always I am going to create base class pointer created, and it is going to point to derived class object. Now, ptr arrow print is a virtual function, so which print function will be called? Print derive class. Show is a non-virtual function. Early binding, so which function will be called? Show base class, because in case of non-virtual function, in case of early binding, it is going to see the type of pointer. So what type of pointer it is? Base. So it is going to call which class function? Base class show function. If I execute, see here, print derived class show base class. Thank you.